Hello everyone and welcome back to the AI Research Roundup. I'm your host Alex and today is May 4th, 2025. Alright, today we're looking at OptionZero, Planning with Learned Options. This ICLR conference paper was published just over 3 months ago, back in January. So, this paper introduces a way for agents, building on MuZero, to automatically discover useful action sequences, called options, through self-play, making planning in complex games potentially much more efficient. So, looking at the first figure here, it gives a nice illustration of how these options are actually calculated within the decision tree. Alright, on the left, you see the tree itself with probabilities for different action sequences. And then on the right, well, that shows how the option network determines the most likely or dominant option from a given state. It visualizes the core idea of predicting useful action sequences. Building on that option network idea, this next figure breaks down the modified Monte Carlo tree search process used in OptionZero. Alright, you see the selection, expansion, and backup phases. The key thing here is how it explicitly shows choosing between a single primitive action or an entire learned option sequence. This allows the search to potentially go much deeper by simulating the option directly, improving planning efficiency as mentioned earlier. Okay, so this next figure then illustrates the optimization process itself, basically how the agent learns which options are good from self-play. Alright, you see the sequence of states over time, S_T, S_T plus 1, and so on. Below each state, like S_T, it shows the option network's target output, Phi_T. This target is essentially the sequence of actions actually taken in the self-play game, represented as one-hot vectors, ending with stop. Moving to the results, the authors tested this extensively across 26 different Atari games. Alright, this comparison shows scores for OptionZero using different maximum option lengths, like 3 and 6, against the MuZero baseline, which is effectively length 1. Well, OptionZero consistently comes out ahead, particularly the length 3 version, boosting the mean score significantly to over 1050% from the baseline's 922%. This really validates the benefit of discovering and efficiently using these options during planning. So digging deeper into how those options are actually used, this table breaks down the behavior for the length 3 and length 6 versions across Atari. Okay, you see primitive actions, shown as %A, are still most common, over 60%, but options, %O, make up a significant chunk, around 30 to 37%. Interestingly, while about 75% involve repeated actions, the agent also discovers important non-repeated sequences showing strategic option use learned through self-play. Okay, looking at the search tree itself, this table provides more detail on how options influence the MCTS process for the length 3 and 6 versions. Alright, we see options make up a huge portion of the actual tree nodes, over 87%. And while they're used in a smaller percentage of simulations, around 22 to 29%, the crucial finding is the tree depth. Well, using options significantly increases the average, median, and maximum search depth compared to the baseline, showing they enable deeper planning. So, wrapping things up, we've seen how OptionZero lets the agent autonomously discover useful action sequences through self-play, enabling that deeper planning we just discussed. Alright, this clearly leads to significantly better performance on complex tasks like Atari, boosting scores over the baseline. Well, it's a really promising direction for making agents learn more complex behaviors. That's all for this AI Research Roundup. Thanks for tuning in.